Hey guys, welcome back to the channel again. And this is a new video of object-oriented programming where we will do some of the hands-on. Okay, and before going ahead, let's have a quick recap what we have done in the previous session. So in the previous session, we were talking about the file handling. Okay, we did some hands-on as well. And after that, uh, I taught you about like OOPS concept. Okay, so yeah, these are the OOPS concept like what is class, objects, and like polymorphism, encapsulation, and inheritance and data abstraction. Okay, and everything was explained in the whiteboard, I guess. Yeah. So if you didn't get that, please watch that video. Okay, and even though like if you're not getting anything in that video, like if you are coming straight to this video, right? So don't worry, your all concept will be clear because from here itself, like today, we will code. Okay, we will do some of the hands-on. Okay, and with the same hand, like simultaneously, I will explain you on the whiteboard. Okay, so let's see what is OOPS concept. So I already told you, right? In simple word, I this is a bookish definition, I will say. Okay, so. I told you earlier, right, that oops in simple word or in a layman word, if I have to say, it is a kind of like a structure or like a formatted way of writing code, right? To optimize your code or to give the better visibility of your code. Okay, so this is just a uh, formatted way. Okay, so let's see from the starting. Okay, I will explain you one by one and I will do code. Okay, so I told you, right, what is class. So what is written here about Python class? A class is a collection of objects. A class contains the blueprint of or the prototype from which the objects are being created, and it is a logical entity that contains some attributes and some methods. Okay, so I already told you, right? Class is a logical unit or blueprint, right? Class is not a real world entity, but class contain some of the some of the, I will say, methods and attributes. Okay, so let's see what that means. Okay, well, open my whiteboard. Okay, now let's see what that means. And let's suppose I have a class car. Okay, class car. Okay, and that car be color will be blue. Okay, and engine is strong, or you can say you can say in horsepower as well, but I don't know what is the technical way of uh, denoting like a engine. Okay, so I'm just writing engine is strong. Okay, and let's say what car can we start. Okay, car can start. Okay, and car have a top speed of 30 kmph of 30 kilometer per hour. Okay, so this is your attribute, as I already told you. Okay, and for time being, just let's suppose like this is your behavior. Okay, this is your behavior. This is your behavior. Okay, now in a layman term, when I will talk about like behavior and all that, so in programming this is nothing but a function. Okay, or method. Okay, similarly like similar goes for here as well. If you can call it function or method, okay. But remember one thing. I'm just explaining you in a layman way. Okay, I'm giving you an example, right? So I'm using this behavior word, okay, or function word. Like function is not appropriate. Okay, I will when I will code, right? You will say like this is nothing but this is a function itself. Okay, so this is function. I know. So in simple word, in simple word, function attached with class class are are known as known as method. Okay, so don't be confused, like functions and methods. Functions and methods, okay, both are same, both are same, both are same. But in when function attached with any class, it known as methods. Okay, and when I'm giving you example, right, then I'm using this behavior word. Okay, let's suppose this car can start. This is your one method, and the car have a top speed of 30 kilometer per hour. Okay, this is your method. Okay, and these color and engine, okay, and yeah, these things are your attributes, right? So let's suppose you have this logical or blueprint, right? This is your blueprint, this whole thing. Okay, let's suppose this whole thing is your blueprint, this whole thing your blueprint, like blueprint, or logical, what I will say, logical thought, I will say. Okay, let's, I'm not getting the proper word, so I use logical thought. And you have to implement these things in code, okay, in your Python code. So how you will implement this thing? So you will implement it by, now I will writing the code here, Python code, okay. First you will use this keyword class, okay. This is your keyword, this is your keyword, okay. And then you will write the class name. So this is my car, okay. So I will use car as my class name, class name, okay. Then I will use indentation, and I will just say color is equal to blue, and engine will be strong, and my car have two facility, like two functionality, I'm sorry. Car can start, and car have a top speed, top speed. So this is your basic syntax, okay. Now I will code it, okay. So let's see how I can code it. So I will use this, okay. Now let's see. So first thing, what I have done, I have to write the class uh, keyword. So I've written class keyword, then I will use car indentation, then I have a color. So I will color is equal to blue, and then I have an engine is equal to strong, and then I have two functionality, right? So I will use def, okay, and start, okay, and you can like print starting the car, okay, and then def speed, okay, and top speed was 30 kilometer per hour, okay. So this will be 30 kilometer per hour. Top speed is kilometer per hour. Okay, so this is how you declare a class. Okay, there is one mistake, and I know what I have done. Okay, not mistake, I intentionally did that. Okay, so can you see? Can I say this is a function? Can I? Because I know what is the error here. Okay, I did intentionally. Okay, let's suppose I will write here like simple this time. Okay, and can I say this is a function? Okay, a simple function. Okay, without any argument, and if I will call this function, so yep, car is starting. Okay, now can I say this is also a function? Okay, this is also a function, right? So if I will call top speed, okay, so this is also a function, right? Now, these two functions are associated with a class, right? We have an indentation, and under the indentation block, this block starts from here and ends here. We have written two functions. Now, this is what I was talking about. Now, this function becomes your method. And remember one thing, whenever you're writing a function, okay, in a class, you have to specify self here. Self, okay, self, okay. What that self is, self, I will tell you about self, okay. But for time being, just think in this way, that self is referencing to this class, this car class, okay. For time being, just assume, like, I will tell you about constructor and all that, so there I will tell you about self, okay. For now, just remember this, that whenever you are writing self, right, also whenever you are writing any function in a class, that method I will say, okay, from now I will say method, okay. So whenever you are writing any method like this and this, so by default you have to give self, here, okay. So let's suppose I'm executing this cell, okay. So I got nothing happened, right? Nothing happened. Why nothing happened? Because this is your logical unit, right? Logical unit. Okay, you declared a class. You declared a class here. You declared class here. Okay, or your logical print, I will say logical print. Okay, so you declared this. Okay, but how can you use it? Okay, for that you have to make an object. Okay, so how you can make an object? Okay, so simple. Let's suppose I have any car name. Let's suppose I have Nan. I will have to write like Nano, but okay, let's see Nano. Okay, Nano, and I will enter and just see this. Okay, now what happened? That this is your object. This Nano is your object, okay. And Nano have all the attributes and all the methods, or all the logical attributes and method whatever you have defined in the car class. So for like cross checking, you can do Nano, okay. And when you will do tab, right, see what all things they have: color, engine, start, and top speed, right. So let's suppose I will choose color, okay, blue, okay. And let's suppose you have mm, one more thing here, nano dot nano dot tab, and you have an engine, and then that's strong. Okay, now you have to call a specific function. So I will do nano dot or method I have to call. So I have two methods. Let's see. So I have to call it, right? For calling a method, you have to use this. Okay. So this is car is at starting, right? And when you have to check the top speed, then how you can check the top speed? Nano dot top speed and enter. Okay. So this is here you declared a class here on your logical print or logical thoughts. Okay. Here here you declared the object. Okay. And here you're calling the attribute. So these things, this one is your attributes. Okay, these one are your attributes. Hmm, attributes, attributes, and this is your behavior, behavior, or methods. Okay, similar goes for this as well. Okay, so this as well. So you have attributes and behaviors or methods. Okay, so now let's suppose you have to build you have to make lots of car, right? Like you have like nano 1, nano 2, nano 3, and nano 4, right? So you don't have to every time you don't have to write this like nano 1 color. Let's suppose have nano, right? Nano, okay, nano 1, and you have a, let's suppose you have a 10 unit, okay, of this similar car. You have 10 unit of similar cars. Every nano have this, like in your stock you have a blue color, you have a like this start and stop speed functionality, everything is same, and you have a 10 unit. So can you see like in a very uh, formatted way, I have done this, right? Like nano car, okay. And let's suppose if I have to do this same thing without using oops, so what I have to do? Let's suppose nano 1, okay, and then I have nano 1 color, because you have to specify, right? Nano 1 color, okay? And then you have to write like blue, okay, and similar thing you have to mention like this: 1, 2, 3, 4, and so on, right? Let's suppose you have a, for time being you have this unit, right? So for nano 2, nano 3, nano 4, okay, and then you have nano 5, and then you have nano 6, right? You have all these things, right? All these things, okay. And for one attribute you are using like the six variable for say like for different variables for different like for the same thing you're using six different variable, okay, and these variable will like take your space, right? For sure, okay. And for time, so let's suppose you have to save the engine as well, and you will declare engine and so on, right? So let's suppose you will do engine as well, and so on, right? I hope you're getting the concept, okay. So you can see, right? This is not formatted, and this even not look so good, okay. So now you can make any number of like uh, any number of car from here itself by using this concept. So let's suppose I'm making one more car here. Okay, let's suppose I will use one more car here. So yep, I will use here. Let's suppose I'm using nano 1 equal to R, right? And see, you can see like I have nano and nano 1 both. Okay, and you can see in nano one I have all the methods and attributes. Okay, so see, blue and all that other stuff, right? So this is the formatted way, more structure, and the visibility of your code is like looks so good, right? Now I hope these things are clear. So first we declared a class, and this is just a logical code, right? Until or unless you will not create an object, you can't do anything, right? For like just you have created a class, right? Until and you have to create an object for using that class functionality, methods, attributes. Okay. So now let's suppose you have one more class, right? Let's suppose I'm using similar example, right? Let's suppose I'm using this example. Okay, now focus very carefully here for a while, because here I will tell you about mm, about what is self keyword and what is constructor. Okay, for timing, let's suppose you're hard coding the values, right? You're hard coding the values like sorry, color blue, engine is strong, and like and def start your method. Okay, and here like method you can method you're using like a method. Okay, here and here you are using like hard coded values, right? But let's suppose I have one car. Okay, and one nano is of blue color and second nano is of red color. Okay, so how you can do so? Like, because if I will create an object from using this class, right? So my every car or every object which I will create by using this car class. Okay, so every object will have blue color and engine will be strong, but I don't want that. I want a class where uh, the color should be different. One should be red and one should be blue. So how I can do? Or one I want like three cars now, like blue, green, and red. How you can do so? So you have to change few things here. So here comes the concept of, I will write this in it. Okay, again I will write self. Okay, again I will use color, and again I will use engine. Okay, and now I will do one thing. Focus very carefully. Okay, now I will do one thing. I will do self dot self dot now color and engine. Okay, now I will create nano r. Okay, then I have car, and let's run this first. Okay, so there is two error, I know. Can you tell me what is that? So let me tell you. Before, there was hard coded values. Okay, now I used constructor. So this is nothing but this is constructor. This this method is constructor. Okay, I used constructor here, and when you used constructor, okay, so here you have defined self. Okay, doesn't matter anything. Like self is like, I will tell you about self. For timing, just forget. Like let's suppose, just think in this way, that self is not here. Okay, so you have given two arguments, color and engine. Okay, so while you're building your object, right? While you're creating an object, you have to specify the things here. Let's suppose I'm writing red, okay, and I'm writing strong, strong, right? Now now I have given us red and strong, right? So let's suppose I will do nano r dot color red, and if I will do nano r dot engine strong, right? Now let's suppose if I will use green, okay, I will do green, and I will say weak, okay. So I will use nano g dot nano g and engine. Can you see the difference? I can make different object with different attributes, right? Different values. And if I want to do the same with the help of, like, let's suppose I have a blue. So I will say blue, okay, and I will just say blue, or I will just say like medium, not weak, or it's just medium. So I will say nano dot color as blue, nano dot engine medium. So you can see, right? I have created one class, okay, and with the help of constructor, right? With the help of constructor, I can assign different values to different object, right? I have created one object here with a different attribute. I created one here with a different attribute. I created here with a different attribute, right? So now I will come to the constructor. So constructor is nothing but, so when you write, you started writing, this syntax will never change, right? When you're defining like def uh, underscore underscore init, okay, two underscore will be there like this, underscore underscore, and you have to init and underscore underscore, okay, and you have to write def, okay, like you do, yeah, like you declare a function, right? So similar to that, when you written def init, right, here def init, and you have written self. So now what self mean? So self means like this, like if you're coming from the from another programming language such as Java, right? So where you, there you have to, there you have a concept of this, right? So self, or if you're very new or a beginner, right? If you know, you not even know this or what is this in Java. So just in simple word, okay, this is nothing but self is nothing but, self is pointing to the main class, okay. So when you are saying self, right, so self, and in simple word is, it's saying like whatever whatever this function take, right, this is associated to this class, this car class, okay. So when you are saying self dot color, okay, and simple color is your value, what you argument, okay, what you're passing, and engine is your argument that you're passing here, red and strong, right? And you're writing self dot color. Self dot color, in a layman word, if I will say, self dot color is nothing but, this is a color of car class, this class. This is the engine of this class. Okay. So I will, in a simple word, like I will write, this is the color of R. Okay. This this is a engine of car. Okay, so in simple English, right? If you have to specify like this car or this pen or any object, right? This lamp. Okay, so how you say this, right? So in programming, I will say self dot color. This dot color is denoting like this color will associated with this class. This color is associated with this class. Okay, so when you're creating an object, right, you're passing red and of self. You don't have to pass any argument. If you're thinking like, okay, here I've mentioned three arguments. Okay, and I'm giving two. Okay. So self first one here and here, right? So you have to specify this is like this like in simple like function you might be saying like if I will say like this here, let's suppose this, okay, I will write anything like self, right? I will say. So now he will now it will say like you missing one required put argument, right? Self, right? So in simple function, if you're mentioning self or anything, it will take that as a parameter. Okay, and you have to pass the argument. But when you're using those things in class, right? So by default, the first one you have to mention self. Okay, so let's suppose you have to specify one argument here or parameter here. So you have to start from here itself. You have to start from here itself. Like you have to give the parameter first, param first, and then param two. Okay, so self will be not treated as uh, your parameter in simple word. Self is by default in the class. Okay, I hope you're getting it. So let's suppose you have defined self. Okay, now color and engine you passed as your parameter. So now you have passed red and strong. So you have created a you initialize the value of an object. So in like yep, I will come back to the self concept is clear. I hope. Now I will come back to the constructor. So constructor is nothing but so whenever you create an object, right, the first method automatically it will trigger, right, will be the constructor if present. Okay, if constructor will be there, so by default, when you will create an object, your constructor will be called. Okay, so when you I mentioned the constructor here. Okay, and I created one object. So by default, constructor taken these two values and initialize these attributes. Okay, here and associated with this object. So this object got color red and this engine is strong. Now, when the constructor, when you got the constructor, right? You got a constructor here, green and V. So this again constructor got called and color was changed to green and engine changed to V. And similar, it goes on for the blue one. Okay, so uh, this is the concept of constructor. Okay, now let's suppose you want to I will say, say, I will just declare one more method, okay, to show you. So, def, and let's suppose uh, overspeeding, right? Overspeeding, overspeeding. I will say self, and I will say speed. I will take one argument, or I will pass one. Yeah, I will pass one parameter or argument. I will say. Okay. So I told you previously what is the difference between parameter and argument. It is nothing but like we can say parameter and argument as well. So it's whenever you're writing uh, here, you call it as a parameter. When you're passing a real values to that function, that becomes your argument. Okay. And if that is not clear, please watch the function video. Okay, where I told you about function and all that stuff. So, and here I will say if speed is greater than 30, 30, okay, print which is overspeed else print no, no, not not overspeed. Okay. So let's suppose I will call this function here or method here. So I will call it nano, okay, nano.r and overspeed, and I will say 20, not a overspeed, right? And 30, if I will say not a overspeed, but let's suppose I have 50. Yes, overspeed. So as you can see, right, it is treating a first parameter here, right, not this one. Okay, so you have to mention self everywhere, and it is not necessary you use self as well. You can use any name here, this, that, and all that. Like let's suppose if, if I will make very simple class, right? Suppose class example example example, okay, and I will say def, and I will use def sample, and I will not use self here, not word. Okay, I will just use this. Okay, and let's see print plug, and I will make an obj object, an example. Okay, and obj dot sample, or hello is not defined. Okay, sorry. So you can see uh, I got the output. So the intention here is like you can see here I mentioned this, or also you can use any naming convention here. So the the official way is like a lot of people, and like even in industry, right, people used to write self. So remember this thing, that you can use, you will use self, but it is not necessary. You can give like any name. Okay, it's upon you totally. Okay, so don't be confused if somewhere some another naming convention is used. Okay, remember one thing: whenever you are whenever you are writing any class, and in that class the first parameter, it is treated like a self, right? So just remember this way. Okay, so now these two things are clear, I hope. Like class and object, because object I already told it is entity, that is state, behavior, associative, that it, okay, and those things you can read the definition. Okay, now we have a polymorphism. Okay, what that it means. So what I told you in the previous session, right? What that I told you, right? I told you about polymorphism. Okay, I will just give you a quick recap. So about polymorphism, uh, let's see. Polymorphism, polymorphism means same method, same method name, but different functionality, different functionality. Okay, so let's suppose you have a animal class, right? Animal class. Okay, or let's suppose you have two classes. One is dog, and another one is cat, right? And you have two method, speak and speak, right? And dog can speak through barking, right? So dog barks, right? And cats are like they do meow. So this two methods have same name, right? But their functionality is different, right? Their functionality is different. So let's suppose you have India, right? And you have USA, right? Here I will say language. Okay, language is one of the method, and here language is also a method, right? But here mostly preferred, mostly Hindi, right? And here mostly mostly English, right? English. So if I have to implement this, and this is very simple, right? So you can see both are same, both are same, both methods names are same. Both methods name I have to write, right? Let's suppose name are same, right? But different functionality, different functionality. So names are same, right? Method name is language, here also language, but here the functionality is like here they mostly speak in Hindi, and here they mostly speak in English, right? And here itself, like they dog bark and cats meow. So if you have to implement it, so you have to declare two class. So let's suppose I will declare two class here. Okay, so let's suppose I have class. Sorry, have class dog and def speak self self. Okay, and written box, right? And I have similar to cat, and I have meow, and let's suppose dog is equal to dog dot, and I will similarly I will create one object for cat also, cat and cat. I will do dog speak, and I will do cat dot speed, and I will do cat dot speak. So you can see both methods are same, speak and speak. The functionality is different, right? Here it is bark, here it is mew. Okay, and similarly you can create an object like create a class for India and USA, and language will be the method. Will be the method. So both the language, both in both the class, the method name will be language, right? But different. What is different? Different is the functionality. In USA, they mostly speak English, but in India, mostly people speak Hindi, right? So this is a concept of polymorphism, and you can achieve in one class as well as many of another programming language allows. So but Python doesn't allow uh, polymorphism in one class, but somehow you can do so uh, through method overloading. Okay, so let's suppose you have to achieve a polymorphism in one class itself, right? You want that I have one function, okay, and it should it should like behave differently, right? So how you can do so? So let's suppose you have a some class, right? Some class, you have def, and you have init, and you have self, and you have number one, number two, okay, and number three is none for sure. Okay, I will take this. So this is by default value. Okay, so I told you in the function itself, right? So remember I told you like when you pass any argument here at number three position, okay, that number will be taken as it is. But if you will not pass any number here, it will be none. So if I will do if number three is not if not none, not none, okay, then return number, number one plus number two plus number three. Else, I'm sorry, why I'm saying in it. Let's suppose addition, add, okay, and let's suppose if number three is none, just pass me as it is. Okay, not none, is none. We'll say is none. I can do as it is. But let's suppose I'm just changing some condition here. So there's none and pass this, or else I will use this. So I'll just change a little bit condition here. So if number three is none, then return me number one plus number two, else return me number one, number two, and number three. So if I will create an object obj dot is equal to sum, okay, and I will create obj dot add, and if I will do one, and I will do, right? So I got three, right? But if I will give three arguments here, let's suppose four, right? So it will give me seven. So even here I'm achieving polymorphism, right? Even here I'm achieving polymorphism. But it is like polymorphism in Python it doesn't support that because uh, it is a concept of method overloading, right? So Python doesn't support like it support like while Python doesn't support any traditional method of method overloading, right? So this is a concept of like polymorphism where you have in simple word you have a similar name, right? We have similar name, right? Add and add, but you can see right here I'm passing two arguments, I'm getting the output. Here I'm passing three arguments and I'm getting the output. So this is the concept of uh, polymorphism, and I will tell you in brief like about method overloading as well. Well, it is just like I'm starting this series right of object-oriented programming language, so I don't want to make things very complicated. So that's why now what is the benefit of method overloading? So, and so just you can assume, right? You have a different class, okay, and in that class you maintained one function, right? You maintain one method with a name, right? But let's suppose you are making and working on any project, right? You have where you have to write mathematical equation, and it might be a chance, right, where you have to use the same naming convention, right? So you have created two different class, and in that class they have two different same methods, right? But functionality wise they can be different, right? As you can see here, like speak and speak, right? Both methods are same, but the functionality, one returns meow and one returns bark. Okay, now the concept of inheritance come. Okay, so what I told you about inheritance, like I told you, right, in a simple word, right, in a simple word, what is inheritance? So I told you in the previous session as well that in the inheritance concept, so let's suppose I will explain you here. So let's suppose, let's suppose I told you in the previous session as well, but let's suppose there is a father, okay? Father, okay? There's a father, okay? And father have attribute of eyes, right? Eyes as blue, right? And this functionality got inherited inherited in his child. Okay, so now so now I can say child got some child got some functionality from his father. Okay, so in a very layman term, right, when you see any child, okay, for the first time in your family or somewhere, right, you might see people like you might see like people say like, okay, your nose looks like your father, your eyes are like from your mom and all that stuff. Same concept as here, right? So when a class is uh, having a property of some another class, that mean like let's suppose there's a class A or class father, right? Let's suppose I have a class father, okay, and I have a class child, right? And class child got some functionality from his father. So now this is your child class, and this is your parent class. Remember always, whoever whoever is inheriting the property from another class, that will become the child of his class. Okay, let's suppose class A and class B. Okay, now class A is inheriting the properties of class B, right? So now class A will be a child, will be a child class, and this will be your class B will be your parent class. Why parent? Because class A is having some properties from class B. So class A is having some property, some some functionality, I will say some functionality or some properties from B, right? Now this will now class A will be your child. So there are many types of inheritance. Okay, so let's see one by one. So just single inheritance, which will be like simple class B and class A. So now class A is giving, this is your parent class, child class, child class. Because arrow is downwards, right? Arrow means like now B is having some properties from A. Okay, or I will say functionality as well. Functionality. Okay, now we have multiple inheritance. Okay, so what that means? Multiple inheritance. What that it means? Let's suppose this is a father, this is the mother, like this is father, this is mother, okay, and this is their kid. Okay, now this will be a child class, and now they both will be the parent class. Okay, now we have mm, now we have multi-level inheritance. Multi-level inheritance. Okay, so let's suppose you got this is the grandfather. Okay, your father got some property from him or functionality, and you got some functionality from your father. Okay, get. Now this will be your base class. Okay, base class, base class, intermediate class. Okay, and this will be your child or derived class, I will say. Sorry. So you can see like there is a multi-level inheritance. Your grandfather gives some functionality to your father, and your father got some given you some functionality, right? Then we have a hierarchical inheritance. So let's suppose, and these all things are very important uh, with respect of like uh, your interview. So remember these things. Hierarchical. So inheritance. So let's suppose this is the father, okay, and This is kid 1, this is kid 2, and this is kid 3. So one class is these all class are inheriting the properties from functionalities from the uh, parent class, which is father. Okay. Then we have hybrid inheritance as well. So hybrid is nothing but let's suppose mm, let's suppose hybrid. Okay, hybrid. Hybrid clustering. So let's suppose I have father, right? And this is kid one, and this is kid one kids one, and this is kid one kids two. Now this is kid two, this is mother. Okay, so now you can see this is the father. This they got two kids, right? Kid one and kid two. And kid one do not have any functionality of his mother, but kid two have a functionality, right, of his father and mother both, right? And this kid one is passing the functionality to their kids. Okay, kid one kids, okay, kid one kids, and kid one kids two. So, and you can see like there's hybrid. So this is all about inheritance again. So I will explain you about one more time. So here you can see I have a two class, father and mother. They have a two kid, kid one and kid two. Kid two have a functionality of mother and father both, but kid one do not have any functionality of his mother. Okay, kid one do not have any functionality of his mother, and kid one is passing those functionality to his kids. Okay, now hierarchical clustering, you can see there's one parent class and three are inheriting from that same class. And then we have multi-level inheritance, like your grandfather have some functionality and he gives some functionality to his father, and you got some functionality from your father. So yeah, these are the things, and I hope this is a very like easy thing. I hope you are getting those things. Now let's do uh, some like some mm, some hands-on. So if I have to do hands-on, right? So let's suppose I have a class father, right? Simple hands-on, okay? And I will do eyes is equal to blue, right? Let's suppose for now there is one functionality. I have a class kid, okay? And I will do father, okay? I will just I don't have like nose is equal to long, right? Let's suppose I have a kid object, kid object. Let's suppose kid dot eyes blue. So as you can see that in my kid class I didn't mention anything about eyes, right? But how I inherited that class, I just open the bracket and pass that bracket here like father. Okay, So that ice blue color, okay, got inherited or injected in kid class. Okay, and when I created an object of kid got a functionality of ice as well, which is blue and which is inheriting from here itself. Okay, so this is a concept of which this is a concept of single inheritance. Single inheritance. Now, let's suppose I have two class, right? Mother, okay. Mother have a nose long, right? And I have one more class like kid or class class kid. Okay, I'm just letting pass. Okay, and let's suppose what that means. Okay, yeah. So I have father. I will inherit the father functionality here and mother functionality here. So I will do mother. Okay, so you can see and kid dot nose. So as you can see, right? I didn't declare anything in this kid class, right? But I got eyes. I will say like I will do like this print. Okay, so you can see I got both the functionality eyes and kid knows as well. But in my kid class, I didn't define anything. So I'm inheriting the functionality from father and mother. Okay, so this is the second example. Okay, so if I will like this is a single inheritance example of single inheritance. Okay, example of example of what? Example of multi-level inheritance. Okay, or multiple inheritance. I'm sorry, multiple 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 inheritance. Okay, now let's suppose I have one more class. Okay, let's suppose this is a grandfather grandfather having eyes. Okay, this is mother. Okay, sorry, father. This property, oh sorry, this functionality got inherited in father. Father functionality got inherited in kids. Okay, and this is level multi-level inheritance. So you can see there's a you can see right there's a level. Okay, your grandfather got a blue eyes, right? And that blue eyes functionality got inherited in your father class, and then father functionality got inherited uh, in kid class. Okay, so if I will print this, okay, yeah, now even kid have both the things. Even father will have. Let's suppose I will do one more thing. Let's suppose I will create a father object here. Okay. Um, let's suppose father equal to father. Okay. Now father dot eyes. But you can see, right? I didn't declare any attribute eyes here. So where I'm getting from? I'm getting the eyes from here because I inherited that class here. So if I will do here, I got blue. Okay. So this is example of multi-level inheritance. Okay. This is an example of multi-level inheritance. Now we have something called multiple inheritance. I already told you about, right? Let's suppose what you have. Then we have uh, hierarchical. Yeah, I can see hierarchical as well. So let's suppose I have father, okay, and I have eyes, blue, blue, hair as smooth, okay, and then I have kid, as kid, okay, and I got father here, or I will say boy, girl. So I will have boy class here, okay, I will do just to pass, and I will have go, and I will have father, also passer, okay. Now if I will do go dot go and boy go to boy, then print go dot eyes and go dot curve. Similarly, okay, this is for go, and this is for go, and similarly I will do for would do for we'll write everywhere boy 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 and boy. So yeah, you can see this is example of what hierarchical, I will say. I'm sorry. Yep, hierarchical. Yep. So this is a hierarchical inheritance. So I got like I told you, right? So I will show you. So in hierarchy, what we have? We have a parent class father, and there is one, two, three kids, right? So I have two kids like boys and girls, right? Sorry, boys and girl, right? And there is one parent class. So this is inheritance. Now we have at last we have what we have hybrid, I guess. Yes. So hybrid, yep. I think you can do it, but let's suppose I will do one thing for you. I'll make I'll give you one example here itself. So let's suppose you have let's suppose you have mother as well. Okay. Father, and I have one more class here. Mother. This is my kid one. Okay. And then mother. Okay. And I have kid two. Got father. Okay. And I have kids. Kids. Kid one. Okay. Kid two. first, and I will have kids. Hmm. So now you can see like I have father and mother, and kid one is inheriting all the functionality from mother, and mother and uh, father both, but kid 2 is inheriting the functionality of father only. And then again, kid 1 is inheriting the functionality of kid 2. Okay, and I will write kid 2 here. Kids, kids, kid 2, kids 1. All right, and kid 2, kids 2, I will write. So yeah, now if I have to print, let's suppose I have to print anything. So I will print by here itself. Let's suppose I will print two things here. So I will print, I have to make a class, right? So I will make a class for um, kid1 is equal to um, kid1 dot eyes, kid1 dot kid1 dot nose, and kid1 dot uh, carousel. Okay, and let's suppose I have a comma, comma. Okay, enough to print. Okay, so yes, blue long smooth. Okay, but if I have to make the kid two dot kid is two, you can see just doing a tab, you will see like he didn't got any functionality from his mother, like nose. Okay, so nose was the functionality from his mother, but no, here like you can see like kid two don't have any functionality from his mother. So yeah, this is how like inheritance work. So this is example of a hybrid. I will say hybrid inheritance. Okay, Hy- hybrid inheritance. Okay, so till now we have already covered major topics. But there are two topics left. I know encapsulation and uh, uh, data abstraction. So I will be covering that in the upcoming videos. But till then, you have to revise and do some hands-on. And please come back and comment down if I missed anything, okay, or if I'm wrong somewhere, okay. Like we all are human, right? And we do mistakes. So don't worry and don't hesitate to ask any question. You can comment down in the below, like in the comment section, okay. And I will try to get back to you as soon as I can. Till then, take care and bye bye.